We'll learn here how to determine that a graph represents a one-to-one function. Let's recall that a function f is one-to-one if different values of x yield different values of y. What does it mean geometrically? Well, let's consider the graph of a function. So let's suppose that we have chosen the value x sub 1 and that y sub 1 is the value of the function at x sub 1. So somewhere here I have y sub 1. That means also that the point x sub 1, y sub 1 is on the graph of the function. Now let's choose a different value of x. Let's say this is x sub 2 and let y sub 2 be the value of the function at x sub 2. Now since x sub 1 is different than x sub 2, then by definition of the one-to-one function, y sub 1 has to be different than y sub 2. So if I were to plot the point with x coordinate x sub 2, that point would have to have the y coordinate that is different from y sub 1, and that would be the point, for example, here. That means, as far as the graph of the one-to-one function is concerned, that you cannot find two different points on the graph of a one-to-one function that have the same y coordinate. Since the points with the same y coordinate are on the horizontal line, that leads us to a test that we call the horizontal line test, which determines whether a graph of a function represents the one-to-one function. The test says that if every horizontal line intersects the graph of a function at most at one point, then f is one-to-one. It means that on the graph of a one-to-one function, you can have at most one point with a given y coordinate. So let's look at the example. We have three graphs and let's determine which one represents a one-to-one function. So if I look at the part A, the graph in A, if I draw the horizontal line, let's say over here, you can see that this horizontal line crosses that graph at 2 points, and therefore the horizontal line fails, that this is not a one-to-one function. Let's look at the part B. If I draw the horizontal line over here, the graph crosses that horizontal line at 1 point. If I move it a little bit up, if there is only one intersection point. If I put it down, there is also one intersection point. If my horizontal line falls on the x-axis, there is no intersection point, and therefore the horizontal line test is satisfied, and therefore this is a one-to-one function. Now let's look at the part C. Now you have to be careful, this is a tricky question. This graph does not represent a function, not a function. And therefore there is no point in figuring out whether it is a one-to-one function or not, because it's simply not a function. So if you are interested in determining whether the given graph represents a one-to-one function, you have to first check that you have a function and therefore perform the vertical line test. Once you determine that you are dealing with the function, you perform horizontal line test to determine whether this graph represents a one-to-one function.